will drop. But in case of nodal analysis, we are using KCL, current. Sum of the current entering into the junction is equal to 0. Okay, in nodal analysis, we are going to solve one problem. Let us consider this problem. 5 amps, 3 volts, 10 volt, 1 volt. Draw the diagram. Boys. Okay, listen. Nobody has phone with you. Phone. Alex, you kept your phone with you. Okay, listen. In nodal analysis, listen here. In nodal analysis, sum of the current entering into the junction is equal to sum of the current leaving from the junction. Here we are going to concentrate on load. In KCL analysis, we are going to concentrate on load, isn't it? But in nodal analysis, we are going to concentrate node. How many nodes are there? This is one node. This is one node. No element connected between these two, isn't it? There is no element is there. So the node, it has only one node. Able to understand? You don't consider this is two node because there is no element present here. So the node in this point, the voltage at wherever you are getting, wherever you are connecting the voltmeter, it shows the same voltage because there is no element present here. So this is considered as one node. Let us take V1 or V2. Okay, then here one source is present, then it is also considered as another node. V2. Okay, so here only two nodes are present. Here this is considered as a single node because it is connected in series, isn't it? Suppose I can write this as, that is I can draw this as, this can be written draw as voltage source. Am I right? Can I draw it like this? So that means there is no node. There is no node. Okay, because these two nodes are same, isn't it? Am I right? Able to understand or not? So the circuit has only two nodes. Everyone clear in this? This is one node. This element. This is also considered as one node. V2. The element which is connected in V2 is 3 ohm and 5 ohm. And here, this is also one node. I can draw this like this. Isn't it? These two are in series, isn't it? So I can draw this like this. So that means this is also considered as a single node, isn't it? So you are not considering this as a node. Able to understand or not? Now we are going to, already I told that we are going to concentrate on node. So in this node, what are all the elements connected with this node? In the element connected 10 ohms, 3 ohms, isn't it? 10 ohm and 3 ohm. This circuit consists of current source as well as voltage source. Whatever it is, the circuit consists of current source as well as voltage source. In the previous case in KCL, how do we write the equation? We are going to drop the equation here, that is equal to the sources equation, isn't it? After that, you are considering one loop, 5i1, 5i2, whatever it is, that is equal to, depends on the source, it may be 30, 40, linear. That source, whether it is a voltage source or current source? Voltage source. Here we are going to consider the current source. Current source consider that is equal to current, because what is I? KVL in a closed circuit, sum of potential rise is equal to sum of potential drop. Potential rise means V is equal to, what is the formula? V is equal to potential knowledge, nothing but voltage. So V is equal to I into R. Here we are going to consider current. I is equal to V by R. We are going to write V by R. So this is V1, this is V2, VADB, whatever it is. So this is one node and this is another node. Now I am going to write the equation for node 1. For node 1, going to write the equation. I is equal to V by R, isn't it? So here this voltage, this 10 ohm V by R. Upon V1 by 10 plus this minus this, that is V1, this 3 ohm lies between these two nodes, isn't it? So that is V1 minus V2 by 10. It is a current source, isn't it? The current, whether the current entering into the junction or leaving from the junction. Entering means you should take as positive. Okay, that is equal to 5. V1 by 10 plus V1 minus V2 by 10 is equal to 5. V1 minus V2 by 3 is equal to 10. Now for node, you have to simplify this. Then for node 2, anyone say the equation for node 2? Node 2 V2 by 5, V2 by 5 plus V2 minus V1 by 3, V2 minus V1 by 3 plus V2 by 1 equal to current. It is not equal to voltage. Minus 10. This is plus and right. You are right. V2 minus 10 by 1. By 1. Okay, V2 minus 10 by 1. Is there any current entering or leaving the junction? Is there any current source connected with this node? No. So that is equal to 0. Able to understand or not? Now, these two you are going to reduce these two equations, find V2 and V1 and V2, and you are going to find the current through each element. The question you have to, what is the question? For the given 50, find out the current through all the elements using nodal analysis method. Find current through all elements using nodal analysis. Find the current through all the elements using nodal analysis for the given circuit. For the given circuit. Yeah. Now simplify this one. 1 by 10 is 0.1 V1 plus 1 by 3 is, have you all bring your calculator? Simplify the problem. 0.333 V1 minus 0.333 V2 is equal to 5. Then 0.1 plus 0.33 0.433 V1 minus 0.32 is equal to 5. This is one equation. Similarly, 1 by 5 is 0.5. 0.2 V2 plus 0.333 0. Then minus 0.333 V1. What about V2? 1 plus 0.2 plus 0.33. Whatever. 1.533 V2 minus is equal to 10. Now you are going to reduce the equation by using matrix or by using the equation solving method, whatever it is. Find V1 and V2. I prefer by using matrix method, but only get familiar because here only two unknowns are there. So equation solving is simple, but if suppose three nodes are given, matrix method is better. So I will try to solve the problem for matrix for all the cases. Listen, what is V1? V1 is equal to 19.9. V1 is equal to 19.888. My answer. 19.888 volt. Then V2 is equal to 10.84 volt. Students, have you all got this value? What is the question? The question is find the current through all the elements. What is I is equal to V by R. So we know V and we know the resistance of all the resistance. Can you find the current value? Able to understand. What about the current through 10 ohm resistor? Current through 10 ohm resistor. Current I10 is equal to, what about the voltage here? V1, isn't it? V1 by 10. Then what about the current to 3 ohm resistor? Current to 3 ohm resistor? V1 minus V2 by 3. Isn't it? Then what about current to 5 ohm resistor? V2 by 5. Then what about current to 1 ohm resistor? V2 minus 10 by 1. Okay, find current through each element. Unit is very, very important, student. Current to 10 ohm resistor is 1.988 amps. Current to 3 ohm resistor is 3.01 amps. 5 ohm resistor is 2.168 amps. And current to 1 ohm resistor is 0.84 amps. Is there any doubt in this problem? Are you all clear? Measurements for the given circuit. For the given circuit. Girls, draw the diagram. Draw the diagram. Copy. How many loops are present in the given network? 3 loops. Then you are going to give the name by your own. You may consider this is 1, 2, 3. Otherwise this is 1, 2, 3, 1, 2, 3. Whatever it is, you are going to consider the loop. Here I am going to consider this is loop 1. This is loop 2. And this is loop 3. Okay, 3 loops are there. What about the loop equation for loop 1? Or how do equation for loop 1? Otherwise, how do you write the matrix directly for this case? What is the first element? First element. How do you take the matrix? How do you take the matrix? A, 1, 1, 1, 2, 1, 2. 1, 1 represents what? The elements present in the loop 1. Isn't it? What are all the elements present in the loop 1? This is loop 1. What are the elements present in the loop 1? 1, 3 and 4. 3 elements are present. So 1, 3, 4. The total is 8. Then what is the next one? 1, 2. Here which one is loop 2? This is loop 2. Is there any element present between loop 1 and 2? Enter 1. You should be writing -1. Is there any element present between loop 1 and 3? Enter -3. Similarly, consider loop 2. What are all the elements? This is 2, 1, isn't it? The elements lies between 2 and 1. 2 and 1. 1. -1. Then the element present at loop 2. In a 2, 12 and 2, 12 and 1. The total is 15. Then the next one?
Between 2 and 3.
2 and 3. Here. -3 here. -12 and here. Plus 18 into I1, I2, I3 is equal to, what are the sources present in loop 1? 24. Whether it is potential rise or drop. Depends on the loop that we are going to select. Rise. Yes, sir. It is positive or negative? Positive. 24. Then loop 2. 12. That is rise or drop? Rise. Then loop 3. Okay, ma? The equation is very, very important. First you are going to write the equation, then only you are going to write the training matrix. Okay, ma? How will you write the equation? 8I1 minus I2 minus I3 is equal to 24. Then minus I1 plus I2 minus 12I3 is equal to 12. 12I2 is equal to equal to 12. Minus 3 I1 minus 12 I2 plus 18 is equal to 89 is equal to 0. Then find that I1, I2, I3. Then find the current to each element. This is I3. The current to 2 ohm resistor is I2. This I2 is I2. Current to 3 ohm resistor is I. In the current flow there. I3. Current to 4 ohm resistor is I1. Current to 12 ohm resistor is I2 minus I3. Current to 1 ohm resistor is I1 minus I2. Okay, the current flow clear. I1 minus I2. Current to 3 ohm resistor is I1 minus I3. Solve the problem.